prism. Okay, that's a short derivation. We have diagram here. If you see this diagram, it is visible to everyone? Please let me know. Diagram, the zoom size. Okay. So, okay. So what we are doing here, see what we have. We have this. This is your angle of incident. This is your angle of incident. This is your angle of emergent. This is your angle of refraction. This is your angle of refraction, and this is your angle of deviation. This is your angle of deviation. Okay, these are the things. See once more what you have. You have angle of incident, you have angle of emergent, you have angle of refraction, you have angle of refraction, then you have angle of deviation, then you have angle of deviation. Now we'll start with the derivation. See, in triangle QNR, just focus what I am saying. In triangle QNR, QNR, what in case of triangle QNR? See, not triangle, it's a quadrilateral, not triangle, it's a quadrilateral. In quadrilateral, AQNR, in quadrilateral AQNR. See, in quadrilateral, now we have a property that opposite angle of quadrilateral. See, this is your quadrilateral. Huh? I'm drawing here. This is your quadrilateral. Opposite angle will have angle of what? It have angle of 180 degree. So you will write angle A plus angle QNR will be equal to what? It will be equal to 180 degree. Angle A plus angle QNR will be equal to 180 degree. In triangle QNR, we have R1 plus R2 plus, see QNR. Where is QNR? This is QNR. This is your QNR. In triangle QNR, the sum of R1 plus R2 plus angle N will be equal to what? It will be equal to 180 degree. So this will be equal to plus 180 degree. Angle QNR, it will be equal to 180 degree. So see, 180 degree common. So therefore you can write angle A plus angle QNR will be equal to R1 plus R2 plus angle QNR. QNR and QNR will get cancelled and you will get angle A. Angle A is equal to angle R1 plus angle R2. Okay, you will get angle R1 plus angle R2. So therefore, what you can write here, you can write R1 plus R2 A is equal to R1 plus R2. And what else we have? We have one more thing, that see, this is angle of incident and this is R1. Okay, this is R1. So what we can write in their place, in that place we can write I is equal to, see, we have here I is equal to R1 plus delta 1 and we can write E is equal to R2 plus delta 2. See, this is delta, this also delta, this one also be delta, and then these two are same, this and this part. So you can write and E is equal to delta plus R2. That means in place of R1, I can write I minus delta 1, and in place of R2, I can write E minus delta 2. This is delta 1, this is delta 2. Yes, this is delta 1, this is delta 2. So what further? Further, I can substitute these values here. So what you will get? You will get A is equal to I minus delta 1 plus E minus delta 2. So this will be equal to I plus E minus delta 1 plus delta 2. What is delta 1 plus delta 2? Yes, delta 1 plus delta 2 is delta. So therefore, your A plus delta will be equal to I plus E. Always remember this equation. Huh? Just remember this equation. A plus delta is equal to I plus E. A plus delta is equal to I plus E. Now, if I want to find the minimum deviation. So what? For minimum deviation, I will write for delta is equal to delta minimum when I is equal to E. If delta is equal to delta minimum, see, angle will be minimum when I will be equal to E. So therefore, what you can write here in this case, you can write delta A plus delta M is equal to 2I. So therefore, I will be equal to A plus delta M upon 2. This will be your equation 1. At Q, what do you have? At Q, this point, you have mu1 sin I is equal to mu2 sin R1. And at R, you have, mu1 sin E is equal to mu2 sin R2. So therefore, you can write here mu1 as I is equal to E. See, as I is equal to V, this part will be same. That means you can write this part as same. If these part are same, that means mu2 sin R1 and mu2 sin R2 are same. As sin mu2 are same. Sin R1 is equal to sin R2, and as angle is small, you can write R1 as R2. If you can write R1 as R2, so what you have for A? For A will be equal to R1 plus R2. So your A is equal to R1 plus R2. That means this will be equal to 2R1. That means R1 will be equal to what? Your R1 will be equal to A upon 2. Your R1 is A upon 2. If you want to find the refractive index, so what you will go? You will again go to this equation. See, now again you will go to this equation and you will write at Q. You will write at point Q, your mu1 sine A plus delta M upon 2 will be equal to mu2 sine A upon 2. So therefore, your mu2 will be equal to mu1 sine A plus delta M upon 2 upon you have sine A upon 2. As angle is very small, so you will write mu is equal to. Acha, what is mu1? Permittivity, sorry, what is mu1? Reflectivity. So what is reflectivity 1? Let us consider this is air. In the first medium there is an air. For air your mu will be 1. So here, and sine theta is approximately equal to theta, so you can write here that A plus delta M upon A upon 2. So therefore your u will be equal to A plus delta M upon A. So Yeah, we have one more thing. We have 2 also. This 2 and 2 will get cancelled, but so you can write u is equal to a plus delta m upon a. So therefore ua is equal to a plus delta m. Delta m is equal to ua minus a. So your a will be equal to u minus 1. Okay, this is the thing. This is the derivation. This is how this derivation, this is how that formula comes. Let's solve some numerical base, some question based on this. The first question is, the phenomena of splitting of light into constituent colors is known as. The phenomena of splitting of light into its constituent color is known as what? It cannot be refraction, it cannot be reflection, it can't be diffraction, so it is dispersion. Reflection is different, refraction is different, diffraction is different, and dispersion is just the splitting of light. Let's see the next one. In a prism, the refractive index depends on what? It depends on what? In prism, the refractive index depends on material of prism. It depends on material of prism. Okay, not the angle, neither the color nor the incident.